Okay, let's see some other examples. Here we have the integral of sine square of 2x times cosine of 2x. So to use substitution, first we want to determine the u. Because sine square of 2x, this is sine of 2x squared. Now this function is a squared, so I let u be sine of 2x. Now if u is sine of 2x, du over dx, that will be the derivative of this function, which is cosine of 2x and multiplied by the derivative of the inner function, which is 2. Now we can see that since du over dx is 2 times cosine of 2x, then therefore dx gonna be du over 2 times cosine of 2x. Okay, so I have this term and I have this term. Then the sine of 2x squared, this will be replaced by u squared, and dx will be replaced by du over 2 cosine of 2x. And we have a cosine of 2x in the middle. Now these 2 cosine of 2x are cancelled out. Now the integral becomes like the integral of u squared over 2 du, which we can write 1 over 2 times the integral of u squared du. The antiderivative of u squared is u to the third over 3. So this equals 1 over 6 times u to the third plus c. And because u equals sine of 2x, so the answer is 1 over 6 times sine of 2x to the power of 3 plus c. Okay. So this is our answer. We can verify this result. Suppose I have a function capital Fx is 1 over 6 times sine of 2x to the third plus c. If I take the derivative of this function, what I will get? Because this function is a composite function, the out function is 1 over 6 times x to the third, and the inner function is sine of 2x. Therefore, the derivative of the inner function, the derivative of the out function is 1 over 6 times 3 times x squared which is 1 over 2 times x squared. And the derivative of the inner function is cosine of 2x times 2. So f prime of gx we can write as 1 over 2 sine 2x squared. Okay. And the derivative of capital F is gonna be 1 over 2 times sine of 2x squared and multiplied by the derivative of g, which is 2 times cosine of 2x. Now these 2's are cancelled out. So we have found that the derivative of capital F is sine square of 2x times cosine of 2x. Therefore, capital F is an antiderivative of this function, and that's why the integral of this function is equal to capital F. Okay, now in this case, what if we let u be cosine of 2x? Can we still solve for this problem? Okay, let's see. If we let u be cosine of 2x, if u is a cosine of 2x, so du over dx is a negative sine of 2x and times 2. So dx is du over negative 2 sine of 2x. Okay, now in the original integral, cosine of 2x is replaced by u. So here we have the sine square of 2x. So cosine of 2x is replaced by u, and the dx is replaced by this term, du over negative 2 sine of 2x. Okay, now we can cancel out 1 sine of 2x. After we cancel out this sine of 2x, we still have a sine of 2x inside of the function, inside of the integral. Now this shows us we need to change the u, okay? Because with this kind of u, we are not able to move on to solve for this integral, because this integral contains 2 variables, x and u. Okay. All right. Okay. Let's take a look at this problem. Here we have the integral of x squared times e to the power of x to the third plus 6. If we let u be, this whole thing be e to the x to the third plus 6, then the du over dx, So to take the derivative of this function, we're gonna use a chain rule. So here the out function is e to the x, and the inner function is x to the third plus 6. So the f prime of g is e to the x to the third plus 6, and g prime is 3x squared. So the derivative is e to the x to the third plus 6 times 3x squared. And dx gonna be du over e to the x to the third plus 6 times 3x squared. Okay, now if we use if we use u to substitute for e to the x to the third plus 6, and use this term to substitute for dx, our integral will become x squared times u times du over e to the x to the third plus u plus 6 times 3x squared. So after we cancel out x squared, we still have this x. We still have this x left in the function. Now you may say, okay, since x to the third plus 6 is a u, so I can write this as 3 times e to the u. Okay, now we don't have any x in the function, but the problem is for this type of integral, we haven't started how to solve it. Actually, for this type of integral, we're gonna use a technique which we will study in calculus 2 to solve it. But at this point, we're not able to solve for this integral. So this tells us maybe we wanna change how we choose u. So this way it doesn't work. At least right now it doesn't work. Okay, so what else can we choose for u? Can we let u to be? Okay. So or we can let u be the power of this exponential function. We let u be x to the third plus 6. If this is a u, then the du over dx is gonna be 3x squared. So and dx will be du over 3x squared. Okay. So this term is replaced by u, and this term dx is replaced by du over 3x squared. The integral becomes x squared times e to the u times du over 3x squared, and these x squares are cancelled out. So the integral becomes 1/3 times e to the u du. If we pull out the 1/3. Okay, now we said the antiderivative of a function e to the u is itself. So this so the solution to this integral is e to the u, and we multiply by 1/3. So the answer is 1/3 times e to the u plus a constant. So therefore, the antiderivative to this function, or the solution to this integral, is 1/3 times e to the power of x to the third plus 6.